Panel. Thanks, everyone. So we actually did some research over the last year in collaboration with Ferrovial and Cintra on this whole topic of road data convergence. The whole premise of this was that the value creation in the road data industry is it's stifled, and it's sort of because the services are siloed and disconnected. Paying for tolls, paying for congestion, paying for the gas tax, EV charging, your annual vehicle fee, parking. It's all different services, different entities, all done separately. And not just payments and servicing, also similar data on miles driven, time driven, roads driven on. The same data is collected by different agencies, different companies, nav apps, differently, and multiple times for the same trip. A lot of this is because there's limited incentive. In fact, there's a disincentive, to somewhat share your data. Like an OEM might think, hey, I may lose value if I start sharing my vehicles telematics data with everybody out there. I may not get the right return on the value that is created out of this. There could be privacy risks. There was this whole GM and LexisNexis showdown that happened last year. So a lot of risks, not a lot of incentives, and no stakeholder alignment. However, with the right tech, interoperability standards, and the right regulatory enablers and firewalls, an agile and equitable road user charging mechanism that quickly, immediately replaces things such as gas tax, your annual road user fee, congestion fee, managed lane tolls, highway tolls, tolls on the mass spike right here, can immediately be implemented, and then ancillary services around this can be built up quickly, such as parking, EV charging, paying for other services, safety and emergency, congestion management, billings and payment. So that's a basic primer, building on this, road user charging a mechanism that is built, which these services can be built upon. But still, there are a lot of steps to get there. So that's what we shall delve into in this panel. So John, I'm going to turn to you first, and John is joining us all the way from Detroit, another victim of the flight cancellations. My apologies. So, given your vast experience at Ford and the 5G Automotive Association, can you give us a quick summary of the journey and hurdles for connected car data sharing? Do you see a lot of progress being made over the next few years? And what has happened so far, and why haven't we seen more progress?
Sure, and again, thank you for the invitation, and sorry I have to do this remotely, but I'm sure I'm not the only one, given my colleague Jen is also here with me, and there are probably others. Hope the conference is going well. Bhuvan, I think one of the things that we have to differentiate when you ask the question is the different forms of connectivity that exist with vehicles today. I think people are very aware that there's a modem on almost all new vehicles. There's certainly a large vehicle park of used vehicles that aren't connected. So a lot of my comments will have to do with newer vehicles that have connectivity of some sort. So you have a modem that's helpful to the vehicle in terms of providing over-the-air updates of the latest software updates to help the vehicle run. Of course, the vehicle itself is collecting information about vehicle diagnostics and performance and things that help maintain the vehicle in its proper form. And then there's also the modem is also used for in-vehicle services and entertainment. Increasingly, telemetry is not an onboard thing anymore. It is something that's done through the network or a connection. But there's also a realm of connectivity that Laura and I have dealt with quite a bit, and that's with regards to connectivity for road safety. And this can be done in one of two ways. It can be done through a direct connection, which would require an additional radio or an additional chip on the vehicle. This is what's typically known as C-V2X or PC5. But there's also ways to utilize either a new chipset or the existing modem to provide a lot of road safety information through wireless networks. And there's also a definition that C-V2X is inclusive of that. Many of you know that originally in '99, when the FCC granted spectrum, they granted 75 megahertz, the technology that was prevailing from '99 through basically the mid 2015, 2017, was something known as DSRC. The FCC over 2019 and 20 had an NPRM where they not only reduced the spectrum that was available for the safety band as it was known in road safety, but they mandated a different technology, which was C-V2X, to replace DSRC, given evolutions in technology. How's that going? This whole nother realm of connectivity. There was a lot of excitement for it, I think, originally when OEMs thought there might be a mandate for vehicle connectivity when we were still doing DSRC. And then there was a lot of investigation as to how C-V2X might replace that. What's encouraging is that the public sector, state and local DOTs are replacing the DSRC radios that many of them have deployed. They're adding C-V2X connectivity. They're probably utilizing that with municipal fleets and first responder fleets. But we also see the very early stages of a lot of wireless C-V2X or a lot of wireless road safety data for purposes of first responders, weather, road conditions, and construction. So while it's early days, I think what we see here is, a reflection that the reason that you haven't seen more OEMs necessarily make announcements in the road safety realm and connectivity is that I think that the priority landscape has changed. And many now are dealing with stranded costs, associated with electric vehicle investments. They're dealing with tariffs, of course. There are a lot of other issues that rise above the connectivity issue, but everyone sees the promise of safety, and I'm encouraged by where we are.
So just to build on the last point, is cost the actual barrier, or is the lack of a mandate a bigger barrier for the OEM to integrate, C-V2X in each and every car that they manufacture? And this can be a quick answer.
I think it's a combination of things. I think obviously if there was a mandate or if there was an incentive, let's say, a vehicle connectivity for purposes of road safety were encapsulated within the existing NCAP system, you might see some more OEMs step up, right? And in Europe, Asian nations, you have seen some adoption of connectivity, certainly in China, where the government has mandated it. There are a number of OEMs deploying C-V2X. So part of it is regulatory, not only lack of a mandate, but maybe still some clarity as to regulatory clarity. It's not completely done yet. There's always noise and there's always people asking for that spectrum. But the cost of an additional radio, certainly for direct connection, is certainly that weighs in on program costs as well.
Okay, thanks for that. So Laura, I'm going to turn to you, and I'm actually physically going to turn to you. So building on the points John mentioned, as the head of ITS America, what keeps you up at night? It seems like the tech is there. Cost might not be the number one reason why they're not doing it. It could be, the data quality issue, an interoperability issue, lack of a mandate to do it, and data standards. So how have you, what is ITS America doing in this journey to get us there? And, how do you see this playing out over the next couple of years?
Yeah, so those are all valid, I would say, challenges that we have to address. But I think there's also opportunities. And John mentioned, I think the most important thing to think about when you think about vehicle connectivity, V2X, whether you're talking about direct or networked, is really it's cooperative technology that you're talking about, right? So when you're talking about the direct space, like John was talking about, where you have to put a radio in a car or a radio in the infrastructure, it needs something to talk to, right? So there's a diminished value if you only have, one manufacturer who has that in their vehicle. But if you had multiple, OEMs who have it in their vehicle, well, then actually you're getting more of these benefits. Or if you have, many states, right, or cities, jurisdictions that have the ability to communicate to the vehicles, right, then you have much more value. You're creating much more value both for those players, but also for the end users, right, all of us who are traveling, the traveling public. And so I think that that's a hard sell sometimes, right? A cooperative technology where you basically need everybody to hold hands and jump at the same time is hard when you're talking about, different states and infrastructure owner operators who have, safety is their number one priority, but they have different approaches to how they're dealing with that and how they're getting there and what the exact safety problem is that they're trying to solve for in their own, system. And then when you have private sector companies, right, who also have a high bar for safety, but again, have different ways of how they're solving it. So I think that's one challenge. I think everything you mentioned, I was going to say yes to, right? Whether it's interoperability is a really big issue that we're tackling right now, right? So we see there's actually a lot of innovation in this space, especially when you talk about the network side of things, which is where you don't need the dedicated radio, when you're just essentially, to make it easy, right, you're just transmitting data, right? You're sharing and transmitting situational awareness and key data to road users to help improve safety and efficiency. And maybe that data doesn't need to be sent in, 1/10 of a second because it's not a red light runner. Maybe it is something that has to be sent within a minute because it's, a warning of a crash ahead, right, over a hill that you can't see, or it's a curve speed warning on a rural road, or something where you have a little bit more time to deliver that. What we see is there's a lot of innovation happening, but it's happening, in, I'm going to say, a fragmented way. So, what you don't want is you don't want all of these great solutions and systems that are developed that aren't interoperable across jurisdictions, across modes, and across providers. So you want a national approach. And so that's something we're working on the interoperability and data standards and quality side. All of it is we're working with our federal partners at USDOT around a national framework for digital infrastructure, for how we can effectively share and transmit data in a secure way across these different players in the ecosystem, in a way where it allows for that interoperability we talk about. Personally, our view at ITIS America is we want to figure out, we don't want to get bogged down in developing standards for the next 10 years. We want to figure out what are the highest priority need standards, and then where can we actually, use other tools to essentially innovate and ensure that type of interoperability, and how do we ensure the reliability and validation of that data, which is really important to all the players.
All right, thanks. That was a great answer. So Jen, as someone running a business and a private roadway operator, I actually remember seeing the videos of obstacle on the road from your, I think, Avia example, when I think a car traveling I-66 and it gets a notification obstacle on the road. So can you talk about some of the learnings from because you actually did that and had this this consortium sort of thing, and you have a lot of sensors in the road for your I-66 and other projects as well. Some at the gantry, some along the roadway, measuring vehicle flow, speed, congestion. What additional data or frequency do you wish for? And how do you envision, this improving the road user experience on say, Cintra ferrovial roads?
Oh, great questions. I have an hour, right? I'll start with Laura hit the nail on the head with, in terms of our learnings of our Smart Road initiative that Bhuvan is referring to, it is a chicken and egg problem if we're trying to put infrastructure on the roads that communicate to cars that have a certain infrastructure inside of them, who deploys first. And we always want to be leaders in our industry to understand where it's going, right? There's so many uncertainties, and we want to make sure that we're ready whatever path happens in terms of how communication happens between cars and infrastructure. We did put sensors out on the roads and that had the ability to communicate with vehicles. So they were communicating with our fleet vehicles. That project had a lot of value for traffic operations, right? That data can help us operate our roads more efficiently, safely. But moving forward, we're really looking at deployments that minimize the roadside infrastructure and looking more to over network, to be honest. The types of initiatives that you and Laura were talking about, where can we just be communicating with cars, whether that's safety information or even their tolling information. How are we doing that? Using minimal infrastructure methods. So that's kind of where our heads are at right now. In terms of what data would we like, I think in order to get to this minimal tolling infrastructure future, what's important to us is, right now tolling has a lot of equipment, right? We have cameras and devices that read the transponders in the vehicles. I think all of that will be needed for a while. What we would love to have is if vehicles are going to communicate with us, their position. So where am I? Who am I? Not in terms of a person, but what kind of vehicle am I, right? So we know, okay, you're a large truck that is having a greater impact on the road, taking up more capacity. We can take that into account. Possibly other details such as the occupancy or other data points that help inform the pricing. So we're going to come up with our pricing based on the data of the roadway conditions as a whole. And then the way that we charge customers is based on their usage of the road. So digital data about their usage of the road is what we would be interested in.
So much more customized pricing, based on the type of vehicle and the impact on the road. And I think the other great point that I take from you, Jen, is the minimum tolling infrastructure. We will be presenting the NYC congestion report that we worked on, but just the cost of setting up all the gantries, barriers, and the tolls for the NYC congestion fee was a massive expense. So Nick, how do insurance companies use mobility data? I think there are a lot of us in the room who are very interested in this, but not really sure. We know what usage-based insurance is, but how does mobility data actually get used in this? What frequency or fidelity of data do you need, and how is this collected currently, and how has it progressed over the past decade? So a quick primer on that.
Yeah, great question. If you think about why insurance companies care about mobility data, we're like our largest line of business is auto insurance, so we care very deeply about how people move around and how goods move around. And so as mobility evolves and changes, we care a lot about that. If I take a step back for a second to try to create a level of understanding here, we don't know what the cost of our insurance product is. So in the same way that when you're driving around, you don't know if you're going to crash that day or not. We don't know either. And so what we do is we do our best to use data to estimate whether or not an incident is going to occur so that we can estimate the cost of our product and then deliver it. And so historically speaking, we've done this through a variety of ways. We might look at an operator set of data, like the human, how safe are they, how old are you? Are you 17 years old? You're probably more likely to crash. It's a correlation. We might say, all right, well, what's your motor vehicle record? Have you had speeding tickets in the past? Or have you had an insurance claim in the past? And so you can think that these are useful pieces of information that get more specific about an individual operator. At the same time, we might want to know what's the car you're driving, what's the vehicle. Is this a Ford Lightning that weighs a lot? And if it's a small car, it'll have a very different crash profile than a very small car. So that creates a new change in how we deliver our product. It might be where you drive or the exposure, like how much you're driving on a mileage basis. If you're someone who drives your car 50,000 miles a year, you're much more likely to crash that car in that given year than somebody who's driving 9,000 miles per year. And so we use a lot of different data today, whether we're contributing to databases on those prior insurance incidents or we're pulling your motor vehicle records. But again, these are kind of historic ways of doing it. When you get into the usage-based insurance, mileage data, vehicle data, we're now much more granular. So if you were driving and you accelerated a lot, you had a lot of hard brakes, and you're driving in an urban environment, we now have a much more specific profile of how one individual drives, and we could use that in the formation of our product. And that's on the pricing side of it, where we try to estimate the cost of it. But then you get into the world of, all right, now how do I deliver my product? Okay, well, if you had a claim at this intersection, now can I use your second-by-second mileage data to reconstruct the accident? So when I compare that to the profiles of, say, the police report or the self-report from the individuals in the incident, you can then have a comparison point, which creates a little bit more accuracy in delivering the outcome of it and figuring out how to pay the claim and pay what you owe. And so these are some elements where using this different type of data creates more advantages for us in terms of just being accurate and more quickly in how we deliver our product, which is based on a lot of uncertainty. It creates a little bit more confidence in how we do that.
And I have to ask, sorry.
I was just going to add one thing, which is that a lot of the data you're talking about is now, being used by the state and local officials to understand what's happening on their network, the driving behaviors on their network, and talked about this a little bit, going from a reactive to a proactive approach on safety, right? So if you know that there's hard braking in this certain area over and over, right? That is going to, as an agency, that's going to tip you off to, what is the problem happening here? Why is this happening? What do I need to address, right? Is it just an engineering solution? Is it a technology solution? And what type of intervention do I need? And it's this type of data is actually really rich for the public sector who's trying to operate the system more safely and efficiently to understand how the roads are being used in a way where they don't have to wait 2 years or however long for this data on crashes and other things to now all of a sudden become available.
So you mentioned hard braking, and let's just double click on that. So I think for insurance companies, hard braking is one of the key indicators of a risky driver or a more crash prone driver. and I think it's maybe 0.3G, the threshold. I may be mistaken. So how is this being measured right now? Is it through a dongle? Is it through a cell phone app, the accelerometer on the cell phone, or is it actually telematics from the vehicle, from the wheel speed sensor being transmitted to the insurance company?
Yeah, the way that we measure the hard brakes or different elements of distracted driving is around different variables that we use. Historically speaking, it generally started with, I would say, mostly OBD2 devices back in the day when we started getting mass market. These devices that kind of plug in onto your dashboard. We would, get them from a third party. We would then contract to ship them out, and we would have the, data be transferred back to us so we could estimate it. And that's how we would typically do it, because in the past there wasn't really a place to go get the data from a connected vehicle. That process evolved over time to be collected with different types of devices, whether it's Bluetooth beacons and accelerometers and them, to now what's predominantly mobile phone capture, where we work with companies like Cambridge Mobile Telematics and others who that's what they do for a living, and then insurance companies often embed their technology in our mobile apps so that the customers will be driving around with that. They'll be collecting trip start, trip stop, acceleration, distracted driving, and more. And that's for us been really powerful because it's been able to reach a broad number of customers. Whereas one of our goals is to have as many people have the supply to as many people as possible. And when you go from devices to mobile, you reduce the friction associated with that. So now a lot is in mobile phone, I would say predominantly. With that said, we all have been working to wait for the evolution of connected vehicles so that we can capture that, which is ideally have a lot higher level of granularity. It's not your phone bouncing around in the cup holder. And the insurance industry does use that today. That is active. With that said, as you mentioned before on the data standards, it's pretty fragmented in how that data exists. So like with one OEM, you might be able to get time really well, but maybe not harsh brakes. With another, you might be able to get harsh brakes, but not harsh acceleration in the same way. And so trying to create an algorithm to accommodate all that is certainly a challenge. But we very much see that world as being productive, because the other fact of the matter is when you get that information and you don't have to collect it, say, after the policy starts, you might know something about your customers before you ever even insure them. And you could use that in a variety of ways. So we're very much encouraging of it. The insurance industry uses it today, but given the small percentage of connected vehicles that share this data in a standardized way, it's going to be a multi-decade journey to kind of get that into critical mass.
Fascinating. John, I'm going to turn to you. So Nick just mentioned that they do get some of the harsh braking and sudden acceleration data from the vehicle cars, but it's a small percentage. So if you can share any figures on what percentage of the 285 million US park is actually connected today, that would be great. And the other aspect that I want to ask you is the use case that Nick shared. A lot of this data is being ingested, and insurance pricing policies and premiums are being outputted. So, but these are not real time. It's not safety critical. Even Laura's example of the obstacle on the road, not really safety critical, as in latency of less than 1 second. But suppose at an intersection you cannot see the pedestrian because somebody taking cutting across you, and you are in the car, and that is safety critical. So do you actually see that non-safety critical use cases will be implemented first, just because of the lack of risk? We heard this in the AI and mobility panel as well before this, where it's the risk in mobility that is actually slowing down some of the adoption of these technologies. So are we going to see non-safety critical applications first, and then these applications where less than 1 second latency, pedestrian ahead, and maybe it automatically applies the AEB on the car, the automated emergency braking. So US park and non-safety versus safety critical.
Yeah, I don't have exact figures on the US park, but as I mentioned earlier, the vast majority of vehicles at the US park are used vehicles. And I would hazard a guess that even with expiration, because vehicles are lasting longer, 10 to 12 years as opposed to shorter life cycles in the past, perhaps maybe a quarter to maybe at best case a third of the vehicles at the vehicle park writ large are connected. But certainly all new vehicles and vehicles within the last 10 years, are all connected vehicles, if not in the last 15 years. You raise a good point. I do think that in terms of getting the driver and the consumer comfortable with the services that can be provided for this, you're going to see these non-safety cases likely be the launch applications. So whether it's tolling, whether it's first responder or emergency vehicle awareness, road construction, weather. There's a whole total VMT or road usage. All of these things could happen first, so that consumers can understand what the technology is capable of, and then layer in things like safety critical devices, which of course we would argue that depending on the use case, and if you're going to begin to integrate the technology with ADAS features in the car, you definitely want a minimum amount of latency in terms of the signal being transmitted and received, and the vehicle being able to react to it. And for those types of connections, I think OEMs would always want to rely on direct connections. But that's an evolution, I think, to that. Perhaps at one point we saw those, more prevalent or at launch. But what we're seeing is some of these other wireless use cases being used. And Nick raised a good point too. In addition to the vehicle modem, any additional radios for things like direct connections, of course, we're all carrying our cell phones into the vehicle as well. And right now, you're either streaming music or using Waze. But that device obviously could also enhance driver information and how it's presented. We really do have to think too about the driver as an individual, the ergonomics, about all the information that will be hitting them or could hit them if we fully enabled all of this. I mean, imagine driving in New York City, which I don't tend to do. I tend to take cabs or Ubers or Lyfts or public transportation. But you know what it's like in an urban environment, whether it's pedestrians, whether it's scooters, whether it's bikes. And if your screen in your car is going off, at a frequency that becomes annoying, the technology will not be adopted, and people will just turn it off. And so the things that we hope to accomplish through awareness of other users of the road or the environment will just be rendered moot if people feel that it's just too much information to be digesting. And I think a lot more work has to be done in terms of what's the right amount of information to get to the consumer and what's critical.
Thanks.
Thanks.
Laura,
Laura,
I'll
I'll
just
move
move
to you because in our call you mentioned
about
about not trusting the data.
Mhm.
So will the OEMs, not, as John mentioned, not trust the data, and it doesn't come, directly to them? I think the car is not generating it, it's coming from, a third party DOT sensor on the roadway, and they're like, oh, I can't trust this to trigger my AEB. Because that's where the real benefit may be seen, where, we actually may save lives and reduce collisions. So your quick thoughts on this?
So I think there's work to do on that front, obviously. I think there's different standards right now. I'm using the word standards as not with an actual standard. There's different sort of standards within the private sector for data quality, right? And in the public sector for data quality. And those need to come together. And we need to come to a point where, again, where the OEMs say, I do trust this data that is coming from an external source, whatever that source might be. Particularly if you're saying, I want to integrate that data into the functionality, the safety functionality of the vehicle. And I think you can get there. And in the direct world, that John and I have worked in for quite some time, you have robust standards, you have very robust safety protocols, security protocols. And so you do have an environment where there is, I'd say, more trust and more verification on those messages. But what you do still have to a degree is implementation differences on the public sector side. So perhaps how, one state might implement the same standard versus another state might be slightly different. And that causes a problem for an OEM who needs one consistent implementation across jurisdictions, right? On the the network side, there need to be more development of standards, and there does need to be this, I don't know if the word is validation or verification of data quality. And a great example is the work zone data exchange. Like, there's a standard for work zone data, and that's great. And that is a good start. But if you have a 2-mile work zone, and let's just say MassDOT, enters that information in at, you have a 2-mile work zone for 18 months, and it starts here and it ends here, what is that actually useful for the driver? And is an OEM going to integrate that information? Or do you really need to say, well, this information needs to be updated at this frequency, right? And it needs to follow the actual work of the work zone, so that when the driver gets that alert, to what John's point, the driver gets that alert, there's a work zone. If they look up and there's no work happening, they're going to say, well, this data is garbage. And, they're going to start to reject it. And that's what you don't want. So there's this issue of, again, I'm saying data quality. It's really that verification and validation and kind of everybody maybe having the same, standard level for that data and how often it will be updated.
So Jen, moving to the I-66, obviously for that stretch, y'all maintain, data very, very frequently, with this whole data repository. Where is the work zone? Where there's a lane closure? Where's the breakdown object on the road? So if to Laura's point, we actually achieve a system where everybody's adhering to the same standards of data quality, akin to, say a GTFS, do you think there could be a global road feed specification or whatever where along with Cintra and Ferrovial, other DOTs, state highway operators, federal highway operators input, data on work zones, vehicle count, speeds, and then this data, it could be wind-based, it need not be wind-based. If it's wind-based, an insurance company could be a client of that repository. It gets firewall data for maybe a heartbreaking incident for a particular vehicle, and then it alters its premium. So do you think this is something possible in your 5, 10, 15 years down the line, or it's too utopian, everybody has their own different standards, different frequencies of updating the work zone areas in the system? Just curious for your thoughts.
I mean, I'm optimistic. I don't think it's too utopian. I think it's important to mention that infrastructure owner operators, so that would include ourselves, that would include DOTs. We typically have information on the system, right, on the traffic conditions. We don't typically have information, you mentioned VIN, on the individual drivers. So I'm not going to be able to give information to Nick that would be helpful in that regard. I mean, we do have enough, at a gantry to say, okay, this transponder went through at this time, or this license plate is associated with a vehicle that is a heavy commercial vehicle.
So what if you're doing away with the gantry and the dongle, and it's all vehicle based for the managed lane fee payments? So, you're saving money there, and you're moving totally to a vehicle based managed lane or a congestion fee charge.
Yeah, I mean, two things. I think that the data about the system is helpful, right? That feeds into a lot of these safety alerts, right? Where is there congestion? Where is there an incident? I mean, we know these things first, right? We're monitoring every inch of our roadway all the time. So that data is helpful, or could be part of this, or the work zones, like you mentioned. The individual driver data, I don't know that we would have kind of individual information. I would see that data possibly coming, the OEMs having the data on where their vehicles are and what that vehicle is. And then certain pieces of that information go certain places for different use cases, right? Like pieces of that information would go to toll operators when they need it, and then the toll operator can process the transaction. But it wouldn't be, I don't think we would be the source of that, but we would be the source of like condition level authoritative data, if that makes sense.
Yeah, vehicle flows and speeds and headings at a system level.
Right, and incidents and non-recurrent congestion queues, that sort of thing, supplementing, what's out there already as crowdsourced data, which the private sector has been really great at providing. It's not an authoritative data set necessarily, so some collaboration combination of the two could be something quite valuable.
Yeah, makes sense. Nick, last question. I see we're at time. So Tesla has its own insurance product, and I assume most of it is from the vehicle telematics data, because they have access to all the Tesla vehicles fleet. So suppose you had access to all Honda, Acura, Toyota, GM, Ford. Could this be a future scenario where you're getting everything from the vehicle? You don't need a OBD2 dongle, a Bluetooth dongle, a mobile phone app that is moving around in the cup holder. And it's very accurate today, but a vehicle sensor data is way more accurate. So
yeah, I mean, it would be a great future rule if we were able to have all that access come directly from the connected vehicles themselves, whether it's Tesla or any other. I think in that case, for what it's worth, they use both the driving data from their vehicle as well as the operator profile, like I mentioned before, how many more vehicle reports, et cetera. So you probably would do that in tandem. But we'd very much be pleased with the world where we would use that information at a much more granular level, where we have built and continue to build out infrastructure for when that world comes. And then it allows us to do a lot of other things too. I mean, we talked about autonomous vehicles and how that's evolving. You know, if you think about when the car is being driven by a human versus when it's being driven by the car itself, we care about that data element because it might trigger different coverage. It might be, the personal insurance policy of that individual driving when they're driving in human mode, and it might be on a commercial insurance policy managed by Tesla or others when it's in the unsupervised full self-driving mode. And so there's a lot of effective use cases where we take advantage of the information to provide better coverages, better estimates of what the price should be, and so we very much are looking forward to a world where that comes to fruition.
Thank you. Please join me all in thanking the panel. Jen, John.
Nick and Laura, thank you so much.
Thanks for everything, and appreciate all the comments I'm getting from folks. I know I was born with a face for radio, and Zoom always puts on 10 pounds. Just know that. Thanks.
Thanks, Jen.
You all
Thanks,
so